Hey, everybody. Welcome. Let's check our audio. Can I hear everyone?
Hello.
Hello, hi everyone.
Testing. Hey.
Hey.
Isn't that what you're supposed to say? I don't know.
Something like that.
Yeah.
Testing 1, 2, 3, 1, 2, 3.
All right. So I'm really excited to have the three of you here with me for the wrap up of ZK Hack Mini number 3. This is our third session. And I feel like what we haven't really done in ZK Hack is kind of do a look into the larger ZK picture, like what's going on in. Oh, did we lose Tarun? I guess so. Oh, well, I'll continue with my intro. We don't always get a sense for like upcoming research or what people are talking about, what topics are people thinking about. And I was hoping to use this session to do that. I do also want to welcome people in the chat to put comments, questions, because we actually, with this format, we can bring up your questions onto the screen, which is kind of a cool little feature we wanted to try out. And I do think it would be fun for this to be interactive. So, but maybe to kick off, why don't we do quick intros to everyone here with me? So, well, Kobi, I think people know who you are, but maybe you can give a little bit of a background on what you do and what you're up to.
Yeah, sure. So I think some people know me already here from what I'm doing with ZK Hack with all the puzzles. But yeah, the other things that I'm doing in life right now is that I'm a partner in Geometry, which is a research-based VC fund, and also cryptography itself.
Cool. Pratyush?
Yeah, hi everyone. So yeah, I'm Pratyush. I recently wrapped up my PhD at Berkeley, and now I'm working at Alio as a cryptographer, working on our implementation of ZC as well as our proof system.
Nice. And Tarun?
Hey, I'm Tarun. I work on DeFi stuff at Gauntlet, and then also invest at Robot Ventures, but have kind of been a ZK circler. I wouldn't call myself a expert, but try to figure out which parts of DeFi can actually work within ZK land.
Cool. All right. As a kickoff question, I wondered so I shared a few of these the lead up to our panel, but I was curious to ask each of you, what do you think the most surprising thing has been in the ZK space? This could be an innovation, a trend, or a new finding. And maybe we can cap that as like in the last year. David's asking, why is Kobi not more? But yeah, I don't know if any of you want to jump in on that.
Most surprising. I don't know, I guess sort of the pace of companies which are sort of trying to deploy more sort of beyond just, I guess, simple transactions to actually support computation. I think in the past year, we've sort of seen 2, 3, 4 projects sort of release. And I think maybe the other thing is that sort of the progress on sort of the ZK AVM efforts. That I guess took me by surprise. I was not expecting. I guess they're still sort of in the prototype phase, but I'm seeing a lot more sort of announcement on people actually saying, "Oh, we can prove an execution of a Solidity smart contract in zero knowledge."
Yeah, I think.
I guess.
Oh yeah.
Oh, go ahead. Sorry, Kobi.
Thanks. Yeah, I think. I think one thing, maybe not surprising, but impressive that I've been seeing is that there are a lot more people getting in and trying to do ZK across very, very different kind of projects, and people that have not known anything about cryptography and are able to create pretty complex and impressive things. And that's also due to a lot of other efforts that support them, but that's really cool. And I think maybe something surprising, I don't know if it's last year, but at least it was surprising to me that I was expecting that things like universal snarks would be slower than previous ones. but we eventually got to know that long and lookup and all these kind of new constructions were eventually extremely expressive and allowed to do very, very interesting things very efficiently. So I think that's maybe something.
Tarun, you were about to say something too.
Yeah, I think the main thing to me is people really focusing on hardware acceleration and realizing that that's sort of like a bottleneck that can actually be both designed around, but also sort of better compilation tools, better sort of like circuit reduction tools, things like that. Like kind of seemingly boring things, right? They're not like the coolest math, but they're kind of like the things that get you like 20% increase here, 20% increase here, 20% increase here. And like you get this compounding of all of these things to make these things a lot faster. And I think a lot of that engineering work is starting, some of it kind of in the pure software virtual machine side, like on the EVM side, but also a lot of it, I think on the hardware acceleration side, we've just seen way more teams, companies, a lot of people who probably didn't know what a zero knowledge proof was 2 years ago, but who are really smart are now all of a sudden kind of like paying attention. So
thinking about that. I mean, one of the surprises I would put here is actually this blurring of the lines between Starks and Snarks, and the using of the techniques kind of going back and forth. And maybe that's always been there, but for me at least in the last year, it's become more pronounced. And I think the idea, like with Plonky 2 and actually the work that Jordi was doing on ZKEVM, where you're basically using both techniques to achieve something, I thought that was pretty cool. So that would be a surprise. My next question is actually, what have the biggest disappointments been?
I think if I would put like a disappointment is that we don't yet have a wide ecosystem of general purpose snarks deployed that can talk to each other. I think the closest thing to it right now would be what's happening on Ethereum with precompiles from a few years ago that allows you to verify some very specific kind of snarks, and that's changing. Like Elio, for example, launching is a game changer in that. Mina, and that's going to create a really interesting ecosystem, in my opinion. And in general, I think all the lack of, let's say, convenient tooling support that's accessible to people that are not like super strong engineers or cryptographers, that's something that I would want to be less disappointed in later on.
Yeah, I think I'll sort of agree with the tooling aspect. I think we've sort of come a long way in sort of the technical, the proof systems and so on, right? But and I think like sort of efforts are underway. It's not an easy problem, right? Because it's combining aspects of like human-computer interaction and UX and so on, so that you can get something that's actually usable. But yeah, I think just the lack of great user-facing tooling. But yeah, I think there's good progress being made on it by a lot of teams.
I guess from my end, and this might not be like as exciting as, hey, we need better tooling, like, or hey, we have Leo, or something that is supposed to replace CIRCOM. It's kind of amazing that CIRCOM has survived and still gets used as long as it has. But I think it's surprising we haven't actually seen that many like very clear translations of applications from normal layer 1 land right now to ZK land. Like we're like Dark Forest is awesome, but I feel like there's like this whole thing that's been promised for a long time of like private X, and We just haven't seen that many actually live, I guess. And then part of that's tooling, so maybe it's a second order effect. But
yeah. Mhm.
Actually, another
Yeah, I think,
question.
as you said, part of it is.
Go ahead.
Oh, sorry. Go ahead.
I was going to go on a different topic, so you should totally keep going.
Okay. And I was just saying that part of it is tooling, but also it's just sort of difficult to actually construct these private protocols, right? Because okay, it's one thing to know ZK snarks and the properties they provide, but then you have to actually integrate into your application and figure out what is the privacy guarantee you want to go for, what can you actually achieve with your system, and unfortunately, I think you still need some sort of crypto background to be able to do that reasonably.
Yeah, I think that's completely right, and I would even add that sometimes we think of snarks as like the thing that will solve everything, but usually it's a component in a larger system, and you need to combine different cryptographic techniques, or even just compose with other protocols and economic guarantees and all that in order to make something happen. And sometimes teams focus just on the snark aspect, and that's not enough to create this translation that Tarun is mentioning.
Yeah, and I mean, we saw the same thing happen, I feel like, in machine learning, right? Where like everyone was like saying like, oh, like neural nets will solve everything. But if you look at the things that actually work in production at scale or like kind of state of the art, all of them are like very hybrid models. They have some features of different things. And you have to understand how the different models work together to actually make the agglomeration. I suspect that will be true here, but hopefully a little less because the surface area is smaller. But yeah, it remains to be seen.
There was a question from the audience. Alex asked, do you think it's really the tooling or the different programming paradigm?
I would say it's a combination of both, because I think one of the things that we've seen that is extremely impressive, in my opinion, is that the fact that we have proper ZK VMs operating today, so things like Cairo and Maiden and all these kind of things, these allow you to actually do go back to the previous model where you're able to write if statements and things that you forgot that you can while you were doing snarks for the last few years. And like this going back to this traditional programming paradigm, I think it did unlock something for people. Like they were able to create interesting things like physics engines on top of these ZK VMs. So I think it's a combination of both, because the tooling is still needed to make these extra efficient things, and even engineers struggle to get into that. But the different programming paradigm definitely is a large contributor to it. Yeah.
Yeah. Also, what Henry mentioned in the chat is that sort of it's a different state model also, in the sense that you have to like sort of in normal execution, you just you have the computation and you have some input state and you execute it on chain and you get the output state also on chain. But in a lot of these ZK applications, you're just pushing the proof of execution on chain. So this makes things like concurrent access to the same state difficult. So overall, there's like a couple of different factors beyond just the tooling.
And I guess one thing I'd maybe add to that is that the side channel effect of that is quite high, where maybe I have a proof that proves something about some property, some function query on some state. But then later in the same calculation, I need to reveal some fraction, some portion of the state. But knowing that this property is true, plus also knowing some tiny fraction, depending on how you do the revelation, you may cause a side channel attack. And that side channel attack is not a fault of the ZKP. That's like a fault of your data access pattern in your piece of code. And, it's very easy to shoot yourself in the foot, I think.
Oh, there's one more question here. Are ZKPs that use trusted setups obsolete? That was actually a question I had as well. Can we say that trusted setups are almost gone? Where do we think we actually stand on that front?
I think we still don't have, beyond maybe, I guess it's like sort of the existing solutions that all lie on a spectrum. Either you get like transparent setup with small proof size but linear verification, or you get transparent setup with succinct verification and largish proof size in the order of like, tens to hundreds of kilobytes with the hash-based stuff, or you get trusted setup and succinct proof size and succinct verification, but then you have the trusted setup. So I think right now we don't have a solution which I guess meets all three of the requirements of like transparent setup and succinct, very tiny proof size and succinct verification. So I think as long as we are in that state, then I would say trusted setups are not yet obsolete.
And that's funny. I remember Kobi, you and we worked together on the Plumo trusted setup behind the scenes. And I remember like some of the work you were doing there was like quite breakthrough. And I was like, this is awesome. We should publish. And you're like, yes, except trusted setups might disappear. It's like breakthrough for now, but will it?
So to be honest, I think for reasons that Pratyush mentioned, not for a long time. And also it really depends on the use case. So for things that you're talking about scalability and rollups, and you can have high latency and one coordinator that combines everything, then it makes sense to use something like a Stark that you can just run the same VM and again and again. It makes sense. But if you're talking about things that are user-facing, then it becomes more complex to argue that because users need to generate their proofs and send them over and put them somewhere, and you need them to be both really fast and sometimes really small. It really depends on the use case. And I think like one tweet that I tweeted yesterday is that you can still have hidden inflation bugs even in a transparent setup. So it doesn't really solve all your problems. It solves part of your problems. And I think universal setups sit in a very nice middle ground that can satisfy a lot of people for a long time.
What is the kind of research or piece of work that has come out recently that really pushed the boundaries, or would you consider like a breakthrough that sort of strikes you as something like in the last year or so? Curious if you felt like there was some sort of paradigm shift at some point.
I would say ZKVM is like one really like extensive project that is taking a huge task that I wouldn't have imagined possible a few years ago. Like,
wow.
I wouldn't have imagined that people would actually take it on. And that's really impressive. And one other thing that I'm just like very curious about recently is like this topic of collaborative snarks. And I think that's a really interesting topic where different provers have different pieces of the witness they want to keep private and then collaborate to create a snark.
Oh wow.
I think this combination of MPC and snarks could be interesting, but I don't know exactly how yet.
Yeah, no, I think definitely. Oh, go ahead, Tarun. Sorry.
Oh, sorry. I actually just wanted to ask you a question about that. Is the like sharding piece, like this secret splitting, like the MPC splitting type thing here going on, is that circuit dependent right now? Like, does how you do splitting depend on the particular calculation? No.
Okay. So I think I also agree that sort of the collaborative stuff is going to be exciting, especially for going back to the private X application design stuff. Where when you have data split across multiple parties, then you really do want to have this sort of collaborative proving kind of model. I think the initial solutions we have right now are somewhat hamstrung by the fact that you do have to have, so they work for like whatever snark you want. They can work for Blanc, they can work for Graph 16, etc. Because what ends up happening is that you have this linear homomorphism, which makes things pretty cheap for the prover. The problem that really pops up is actually producing the witness in a manner that's secret shared across the parties. Because you have to go from, say, like a Merkle tree path to the variable assignments that correspond to the circuit, right? And that step requires standard NPC, and that is expensive. So for some applications, you actually already have naturally secret shared witness data. Yeah, I think I'm very excited to see like where the progress goes on that front in terms of having the collaborative proving various models for particular problems and so on.
Are there any sort of? Well, I feel like we all have a bit of a lag, eh? Sorry about that. Go ahead, Tarun.
I think this might be like sort of a more recent thing, unclear if it will find a use case, and it might also just be because I'm a sucker for VDFs whenever I see them. But I really love the short-lived ZKP thing of like giving access control and lifetimes to proofs. It's not like a very complicated idea. I think it's just more that the idea of like, hey, like there's kind of like a way of saying like, in the same way that you can like revoke auth keys in like a normal system, you can like revoke sort of provability. And I really think that's kind of cool idea. And it actually seems like it might be like a more direct application. So
I want to bring up a question from the audience from Thor, who's part of the ZK hack community. This is about large companies working in ZK for a long time, and we rarely hear about them. Why is that? I can tell you from my side as someone who tries to get ZK teams to come on the show, often there is multiple hurdles to communication in those companies. So even though there's really interesting stuff happening, they seem to have like sort of trepidation sharing things until they're exactly perfect in the way that they want. So that might be part of it. I don't know if Kobi or Pratyush or Tarun, if you have any other ideas why we're not hearing as much from what work they're doing. Do you have any thoughts?
there's a lot of churn, I would say. That's certainly, it's like not zero amount of churn from big companies. And I mean, the first one listed in the question, Meta, has probably had the highest churn. But it doesn't seem like people stay at these places forever, or they like leave very quickly. And so if that distribution gives a weird set of outcomes.
Yeah, I think maybe one other factor is that all of these ZK systems that have been successful, that have been deployed at least, things like Zcash and things of that sort, they require a complete change in how things work, and it's hard to think that Visa or EY will change how big parts of them work, just in order to make this compatible with ZK systems, even in terms of file formats or like things that they could read inside the snark or whatever that could work. And it requires an ecosystem to start. And I think it's easier for a startup to do something like that, to make such a bet, at least. But yeah.
I think that's a really good point about the community. The fact is, to engage in this world, like this part of the industry, the way you do community is so different. And I don't know if these companies are always ready for that. I do want to point out, though, from that list that there is EY, and EY actually does do Nightfall, which is like, there is a ZK project that's like a little bit more championed within their org. So we should give them a little bit of credit there.
That's very true. Yeah.
I think the other thing is that unlike sort of other, like most efforts in the blockchain space, there's not really, the properties provided by the zero knowledge proofs are not really sort of that integral to, critical to the work that these companies do, right? Like in the blockchain space, the point is decentralization, so you don't have a single party that is responsible for running the service, and so you need to have strong integrity and privacy guarantees. For like Meta or Visa, you don't really have a big push for, you just trust Meta to or Facebook to run your application correctly, right? So even when they don't have DM anymore, so there's not, I feel like there's less, it's less critical to their path or whatever, to their mission.
There's another question here that was just pulled up. Is there anything missing in Macy for it to get more adoption, especially for QV use cases? QV?
Quadratic voting, I guess.
Okay.
Yeah.
I wonder, Kobi, do you know this?
I can give my view. I haven't been involved in some time, but I can give my view of where I saw it last. So I think Macy has been deployed in things like ClearFund in order to do quadratic funding, which is a really nice use case for it. And I think that I would put two things in the front in order to see it more widely deployed. And one is a technical problem, which is that currently there is, Macy provides you with collusion resistance between voters. And that works as long as the coordinator in Macy does not collude with others. And something that would be really useful for this kind of system is that the coordinator itself would become decentralized, because currently it's a single point of failure for collusion. So that's a technical thing that I would really want to see improved and might increase confidence in it. And the other is more of a social aspect, which is that it has two phases, I guess. One is that I think that sometimes this collusion resistance property is not widely understood. Sometimes people think that private voting is enough, but it's not really, because you need to make sure that you cannot be bribed. And that's an interesting property that you sometimes miss when you try to do private voting. And Macy provides you with that, but it's maybe not widely understood. And the other thing is that you need good Sybil resistance, because when you do things like quadratic voting or quadratic funding, then you reward more distinct votes from different entities. And if you do not have good Sybil resistance, you're gonna be just paying inappropriately, weighting this inappropriately in some sense. So more confidence in some Sybil resistant identity is also needed.
Kind of on that level, I kind of want to explore some sort of unsolved problems. I don't know if you have a list of things. I mean, we mentioned things we wished we had. It's not necessarily, it's like this one was specific to Macy, but are there remaining unsolved problems in ZK that you think we could maybe even point some of the people in the audience towards, things that they, like research projects, things you'd love to see explored?
I mean, applications. I'm the person harping on applications, but I feel like we still have a lot more research on applications and proving they're secure and guaranteeing, even boring things like, hey, we don't reuse the same state twice when we use this particular mechanism, or the probability of ever doing that is low enough, stuff like that. And that's not a ZK problem. That's just how do I analyze an algorithm that uses ZK and compare it to the non-ZK version, and proving complexity differences for those.
Yeah, I think.
Go ahead.
No, I was saying, maybe touching on that point, basically going back to the state model point that Henry brought up. I think sort of designing, like so far, I guess applications have been designed in this sort of solidity model where you just have a blob of state and you execute the contract on top of that. And your sort of miner or like whatever block producer sequences executions of the same contract in the same block or something like that, right? I think sort of, going back, and maybe I would say in terms of applications, the biggest challenge is sort of trying to figure out how you go from that model of like, everybody touching the same single state to designing applications where sort of the state can be sharded into independent components and people just touch, and different transactions can just interact with one independent part. I think, for example, in the AMR case, right now you update the same reserves, or you interact with the same reserves of the AMM, right? Maybe there's a way to split it across multiple reserves. I don't know, to give you some sort of similar efficiency benefits, but also then allow it to have multiple concurrent AMM transactions in the same block that don't conflict.
I totally agree with all the points, and I think that I would maybe reiterate that we're missing good high-level languages, especially with the most expressive types of ZK systems. Like, because we have already good high-level languages for maybe R1CS, but not for plonkish arithmetizations. And maybe also in that respect, just the fact that it's super hard to argue security for this kind of systems, or not argue, but examine security. So some kind of wider agreement on what's been deemed to be secure and be able to reuse it, and so some kind of, not everyone creates everything from scratch all the time and then doing the same mistakes over and over.
Can you give us, like, on that high level language topic, actually, can you just tell, like, what are the high level languages that do exist so far?
So there is Leo that Pratyush knows really well. And there are like Circom, and there's Noir, there's today things like Cairo. I probably missed Socrates. Like I probably missed quite a few.
But do you feel like that's not enough, or they're not developed enough? Like, what's the issue with that? Because you just listed a couple, so they exist.
Yeah. So I think like that some of them try to hide, or not try. Sorry, some of them try to give you a very direct view of how your circuit looks like. So things like Circom are very low level. You literally like write arrows that looks like you're connecting wires, which makes a lot of sense because you're writing low level code. It's like writing C. And so that's very good when you're confident. But for example, it has no types. So it's that problem. But it's what you see is what you get. Like, you don't get extra constraints when you write Circle, which is really good, like, because for some people. And some other languages like Leo try to give you more capabilities, for example, like conditionals, which require creating a lot of extra constraints just to support that, but they allow you to write that. But still, I think what's missing is a way to create these extra efficient versions of primitives, like hashes and range checks and all this, and be able to use them in higher level languages. I think that the work in progress that I've seen in Noir is really maybe a nice point in the trade-off space, where you still have to modify the language every time you need to add such a thing, but you can support this. So maybe it's a good trade-off. So that's kind of the different levels that I see.
Cool. I want to bring back this point that Achim made, which is improving performance of ZKB and WASM. Is this something that any of you are thinking about or looking at?
Not seriously enough.
Do you think we should be? Do you think this is going to come from, because there are some projects, like, is Solana WASM? awesome? Like which
No.
which large? No, what? Oh, I know Polkadot.
I mean,
is
near Polkadot, near and
Okay.
Polkadot are probably your biggest. Yeah.
So I'm guessing
And
if we want to.
Cosmosm. But Cosmosm
yeah.
is slightly weird. If you ever try writing Cosmosm, it's not exactly like writing normal code. But I think that there are teams on each of those who have been working on proving systems. But empirically, they have taken longer than people who haven't. So I'm not sure. I'm not sure why that is, but.
Yeah, it does sound like though, if you want to fight, it's almost like that those two networks and the work they do on ZK, or the teams building ZK, and that might be a good place to start looking for this innovation if it's happening. There's a question from Ariel. It's a pretty long one. I think I'll bring it up here, but it's the idea of full ZK EVM, full EVM, because there is these different types of EVM. Let's see. His opinion is that for full EVM, not toy, including pairings, all hashes, we need another order of magnitude improvement to get snarks to get reasonable performance. Is this correct? I don't know if I said that right, Ariel. I hope I did it justice. Any thoughts on that?
Yeah, I think, right now I would sort of agree with Ariel on that perspective. But also sort of I think the context of deployment of these ZK AVMs is for rollups, where sort of you pick and choose which applications you want to support. So you don't have, you might not even have a contract which has, pairings or a particular kind of unsupported hash. So right now it's not so much of a concern, but yeah, I think to actually get to full compatibility, we need quite a bit more. I think, as I said, efforts are very, very early in the space.
Yeah, I would agree with that, and that you don't really have to support everything, but you do need to support a very large subset of the EVM opcodes and precompiles in order to claim that you have something interesting and that can, people can migrate to, because otherwise you will just not fit a lot of other contracts. I think that the work that I've been seeing also tries to play with different kinds of modularity that you can use. And like you said, with the work that Jordi is doing, for example, and the work that Data Foundation and Scroll and all these other teams, they're trying to look at how to use different proving systems with different performance characteristics in combination. So that helps a bit. But also, I've also seen discussions on different storage models which don't really affect the EVM opcodes, but they affect other performance characteristics of the system. So that might also help.
I sort of want to start bringing us back to the question of applications. So I want to so far, I mean, we talked a little bit about the privacy token transfer maybe, but I mean, private DeFi is something that has definitely been talked about this year. There's been talk of private NFTs, there's the privacy in gaming, but that's all privacy. It doesn't necessarily, ZK applications, ZK use cases could be wider than that. Are there some interesting ones floating around that have emerged for you this year? Do you see sort of maybe a category coming up, or has it been still sort of the same old? Because I mean, to me, it was ZK version 1 was privacy, ZK version 2 is scaling and rollups. Then there's been sort of these smaller cases, but yeah, I'm just curious if there's I do know that private DeFi has been a topic, at least, that's come up over and over again. We've seen teams pitch that to varying degrees of certitude, whether they could deliver. But there's definitely been some interest there. But that's just one use case. Maybe we can start with that, but I kind of want to spend some time on this use case thing. And I do want to open it to the audience as well. If anyone has ideas here, we can bring up your comments and stuff. Actually, like there's one here, the semaphore use case for ZKID. This is one that I'm seeing here. Actually, maybe we can just pull it up here.
Yeah, I think also the Park, 0x Park folks, they've been showcasing some interesting applications like the stealth drop. Yeah, I think we'll see a few more interesting applications as sort of the tooling matures and people start actually building on top of these protocols. Yeah, in terms of private DeFi, I think there's, I guess, Penumbra, I think, is an exciting project. I feel like the osmosis folks, they were going to do like something like threshold decryption. I don't know where they are on that front, but yeah, I think there's going to be, sort of more people get expertise in ZK and sort of DeFi knowledge or building knowledge becomes more common, then I think we'll see more interaction between the two communities and maybe better design of because you really need like sort of a co-design of both the DeFi and the ZK stuff to get like an efficient protocol.
Yeah, I mean, to that point, I think auctions still are probably the easiest in my mind use case. Like I think all of the public blockchain DeFi primitives that exist now probably are not just drop-in compatible in any way, shape, or form. I mean, obviously AMRs are the easiest example of that, but even the lending protocols are not. There's like a lot of extra state that ends up kind of needing to be revealed in order to do the interest rate calculations. And so, it's going to have to look different if you want to hide blind the, kind of like the borrowers from, identifying the borrower information from like the actual calculation that computes the interest rate at each time. That being said, auctions are definitely the easiest because people have studied blind star, where star means like different sort of like mechanisms for how you decide the winning price, star bid auctions, and that's been studied by economists forever, and no one's ever implemented them because in practice you just trust this, like you trust Google or whatever when you use their ad auction. But yeah, in general, I think is that my phone?
We've been talking too much about zero knowledge, like
the Borg is intersecting. But auctions are actually, I think, the easiest application. Yeah, auctions. Yeah, that's the CIA coming through. But yeah, auctions are, I think, the easiest thing, and for some reason, no one's done them, and I don't really get why.
What does that mean, Tarun? What's the auction case that you're talking about?
I mean, even just an NFT auction, right? Like, think about that. NFT auction is like the easiest case of like, hey, there's tons of people front running people in the mempool, and there's no sealed bid auction, right? All of the bids end up being public to some level, some time scale, and then you can start front running people, and you see this all the time, right? And just designing a ZK NFT auction, even though like it's going to be hard to get market share. I'm not saying this from a like, hey, this is going to be a successful product on day one type thing. I'm saying this more from the point of view of like, hey, no one's actually even bothered implementing like the proof of concept of this. Partially because everyone in NFT land it's like, they don't not really paying attention to ZK stuff. Yeah, they don't seem to care. But I do think like, if you actually build these auctions, there's tons of applications. The first one is like the Flashbots auction. That's not really a sealed bid auction. If I run enough relayers, I can actually guess certain transaction bundles like hitting time with like some appreciable probability. Other auctions are just like, there's tons of auctions in DeFi all over that could benefit these. And auctions have very minimal state, and you don't need to choreograph the state as much. And so, I'm just surprised we haven't seen anyone do it. And I think that's like the lowest hanging fruit.
Would something, and probably maybe not here, but like, would something like Macy be useful in auctions, or would you need to create something like Macy specifically for auctions? Is it a complete new? It's a new build.
It depends. Like, it depends on the auction mechanism. So economic collusion resistance is actually dependent on like how you clear the auction. Like, given all the bids, like what's the final price and what's the final allocation? Because most auctions in crypto, minus NFT auctions, are actually combinatorial auctions of like people are bidding on subsets. They're not bidding on like a single item, right? So it's like, oh, when it's block space, I'm bidding on subsets of slots in a block, right? And so in these combinatorial auctions, they're actually like, there's a sort of notion of like what kind of economic collusion resistance is over like different subsets.
Kobi, Pratyush, were you about to say something?
Yeah, I think you also, saying this, you also, I guess and there's been some work on cryptography for auctions on sort of the MPC literature. So I suspect we might need to do some sort of specialized MPC, but also it depends on the specific kind of auction mechanism. It is sort of a commit and reveal thing for your bids. Still, I think, depending on the specific properties, you might want to still have some sort of MPC, which provides. So I think this also goes back to Kobi's point earlier, sort of that snarks are just one aspect of sort of this private protocol or application design. You need to use not just snarks, but potentially other tools also.
Have any, like on this topic of use cases, have any non-blockchain ZK use cases come to the forefront for you? Have you seen them? Have you heard about them? Does anyone care? It's kind of sad. Like, I feel like to me, there is this chance that it gets used in all these. I mean, Cloudflare used ZK. There's like other ways that it could be used outside the blockchain.
This is another flavor of the earlier question, right? About the big companies.
Mm-hmm.
You think so? What you're saying is they are using it, but we don't know. Maybe.
I think they don't have an incentive to. Again, they're going back like, okay, if I outsource something to AWS, right, and AWS screws up the execution, then having a proof of the fact that they didn't execute it correctly is not really going to benefit me. I just want I'll just terminate my contract and go to like Azure or like GCP or something, or GCE, whatever. Right. So there's no, like, in a lot of use case, and like, I guess traditional tech use cases, it doesn't make sense. I think one area which I think these zero-knowledge proofs could be useful is, I don't know if folks have heard of transparency law, such as certificate transparency, binary transparency, key transparency, all these things. And then the idea really is you have almost like a blockchain, like a ledger of something where you like prove inclusion of certificates or keys or whatever, right? And the idea is that people can check if their certificate or their key has been changed or deleted or without their consent, and they can check it because it's basically like a Merkle tree over this list. But if you want to check it over a period, you have to check every time slot this Merkle path. You could use snarks, for example, to compress that verification time. So I think that's one application area where it does make sense. Snarks are probably too slow right now to handle the throughput of these systems. Like they do millions or billions of updates, maybe billions of updates per day. I want to say, I don't know actually, but it's like much higher than blockchains. But I think that's one area where if we see progress, then it's sort of the incentives align and it would make sense to deploy it there.
Yeah, I would echo this kind of blockchain-like databases, or let's say cryptographically designed databases that you can later use to prove things, the inclusion or just properties about elements inside it. are things that could be useful if they are deployed. There's a lot of a reputation game going on where people still trust a lot of these entities, so I don't think that they feel a pressure to do such extra things. For example, I don't know, you can imagine Filecoin that gives you a proof of retrievability. You can do that for your Amazon storage and then make sure that you didn't lose your data. But it's a lot of overhead, and people just trust them now, and they get compensated if something gets lost. So I don't know, you have some kind of slashing, I guess, happening in real life. But I think it's also like I said previously, it requires a big change in how things are represented and how things work. And reputation is just easier for them for existing use cases. I will say that I thought we would see a bit more movement in identity, even beyond blockchain space. That maybe we would see some more adoption into the integration of zero-knowledge proofs and identity. That might happen.
So I feel like I was going to move off the topic of use cases, but before I did that, I actually thought we should maybe visit one of them that has come up a number of times this year, and that's the private AMMs and whether or not ZK is the right tool for it. Tarun, I know you have strong opinions here. Pratyush, I'm wondering if you're thinking about this at all over at Aleo, or you're not focused on that sort of application side yet? Because I know that their ZK would be at the core. So yeah, is ZK the right tool for a private AMM?
I think it's part of the tooling, but yeah, you need other crypto also. I mean, we've been thinking about sort of private AMMs as part of a larger, problem of how do you support applications where multiple users interact with the same state. So that's how we've been thinking about it at Aleo, and sort of, yeah, you could use tools like NPC. I think there was this excellent post by Vedai on sort of various other tools you can use beyond just snarks to develop privacy-preserving applications. So things like threshold, homomorphic encryption, NPC, all these kinds of techniques, threshold decryption, all this stuff sort of, I think has a role to play in this space. But it's a difficult problem to solve. There's also some impossibility results, like what Tarun worked on. I'm sure there's like ways to work around it with with differential privacy, like what Tarun worked on, stuff like batch auctions, which provide some notion of privacy. But yeah, so I think there's like research to be done, and we shouldn't just focus on snarks as the only tool. We have to. I mean, there's like a lot of stuff in crypto that we can use, and we should use it.
I think what Penumbra is doing with implementing batches and kind of like allowing people to express strategies, but also have like the actual execution ordering being private is like a good hybrid of, say, like something that's event based where you're blinding every event like an order book and an AMM. And I think like end of the day, the hybrid designs are probably going to be superior to like, hey, we just are trying to make it only with snarks, and you're kind of then handicapping yourself. But one thing that's actually kind of interesting is there's a lot of bridges, like cross-chain bridges, that are AMMs on both sides. So Synapse, I guess, is the simplest example of this. But one reason for this, and the big wormhole $300 million hack is related to this, is that let's say I'm going on a bridge between Ethereum and Solana. Well, I have to have sort of like some notion of a wrapped version of Ethereum on Solana that represents how much ETH I have for Solana accounting. And on the other hand, I have Solana, a wrapped version of Solana on ETH that represents the Solana that I've minted on the other side, right? And the accounting is that they should like offset each other. Well, how do you offset them when their prices are fluctuating? Well, one way of doing that is putting them in an AMM on both sides. And something like the wormhole attack, the ZK stuff is actually quite useful for that, because one of their problems there was like, I mean, it's a very low level infrastructure problem of like why someone found a bug where you could double mint, and you could basically, you locked 100 ETH on one side, you minted 200 ETH on the wrapped Solana side. And those are supposed to be equal, but somehow you were able to get double. That's like effectively the simplest version of the attack. I think like ZK techniques for like solidifying bridge synthetics and things like that and AMMs, that's like a totally unexplored but like area that we're going to see things happen as like these bridge attacks keep getting larger and larger in like lost value.
Wow.
Hey, I think we lost you, Anna.
Yeah.
Is he? No, I'm back.
Yes, you're back.
Okay, good. Okay, so I was wondering, where does the ZK in that case happen? Is it in the bridge, or is it in the AMMs on either side?
I think it's like similar to like the like client use case, right? You're proving to another client like that the state is correct on the other side, and it can verify it. And the state here might just be something like, did we mint this many synthetic tokens on the other side, right? It's actually like it's just a like client use case, except bidirectional, I would say. Like both sides are proving to each other.
I'm going to bring up Alex's point here. Sounds like they're thinking on this. Okay, I want to shift gears and talk a little bit about actually funding in ZK. I feel like, and the reason I want to talk about it is there's just been some crazy announcements recently of large fundraisers around zero knowledge tech, mostly so far, I would say, focused on roll-ups or scaling solutions. But I do want to kind of bring this up. And I wonder, like, and it's funny because I think everyone at this table probably either like has invested in or has been invested in. So but I'm curious what everyone makes of it. Is the amount of funding coming into ZK a good, or is it going to the right places? Is it going to solve the right problems? Some of the numbers I've been hearing recently are kind of freaking me out because they're so big on like networks that are only like half launched. So yeah, curious what you make of it.
I think one thing to remember is number go up is very good for attracting talent.
Okay.
All the hardware people, I feel like wouldn't have been that interested if ZK networks didn't had higher headline numbers. If we're going to be honest.
Okay. Brings talent in.
Yeah, I think.
Go ahead.
Okay, I think, and also I'm kind of biased in this front, but I think also I think the sort of existing fundraisers have not, by and large, gone to, I guess, shady or sketch teams.
True.
I think across the board, it's people who have demonstrated in the past some capacity to work on ZK and deliver, I guess, solid ZK products. So I feel like it's not as risky as maybe some of the ICO stuff that happened before.
Yeah, I would agree.
I'm going to pull it up.
Yeah,
very nice.
Good. So yeah, I would agree with those things, like attracting talent and the fact that credible teams got the funding. That's very good. I think it also allows these teams to work on pushing the boundaries in ways that they wouldn't have been able to if they had to work in a more scrappy way. But it is a risk for them in some sense, right? Because if they don't figure things out fast enough, or if they don't time it right with the market, then the fact that they raised all this money and there is no one to accept it, or that the valuation is now way too high, it might hurt them. So in the short term, I think it's good, and I think that some teams will greatly benefit out of it. So in general, I would think it's a plus. And I would say that I also, what I see that I like, which is like different than VC funding, it's the fact that we have a lot of funding for, getting people into this space, and all these grants, for example, like 0x Spark, and these are very beneficial efforts to get talented people up to speed on what's happening and how to contribute, and educate and make sure that people work on things that make sense and not just the flashy things. So I think it's I really like the aspect that we have a lot of grant funding going around.
Totally.
I think that's really useful.
And that sometimes comes through that, like there'll be the big fundraise, and then those teams start to give out grants or just are more generous in their funding of education in the space. I mean, we've seen this a number of times.
Exactly, and it helps that the money went to these credible teams that know where to put it, so that's good.
Speaking of actually education, in that case, there was a question asked in the ZK Hack Discord about, can you hear me okay, by the way? I know I see my own, okay. It was basically about what Web3 cryptography should be taught or learned by students in preparation to be kind of contributing. So this is almost going back to maybe an undergrad or master's level, like what tracks should people be taking in order to really be able to build? Because also, and this kind of makes sense, like just think of the amount of time that goes into the learning at school, and at what point, like where will it be at by the time they're complete? It's almost for 4 or 5 years in the future. What does it look like? What do they need to know?
Yeah, I think existing there's not that many courses which actually teach any of the advanced crypto at maybe like an undergrad level that you would need. So like, so like you have like a computer security course where you learn things like public key encryption and modes of, or like something like CBC, ECB, all that stuff, symmetric key, block cipher modes, and maybe signing, and that's it. And you might have at the undergrad level a theory crypto course where you cover definitions and proofs, but really the kind of stuff that you need for in the blockchain space is not just knowing the theory, but actually knowing how you actually apply it, right? And how you construct systems that use things like MPC and ZK snarks. And there's no course, I would say right now, that actually does this combination. Much to my frustration.
Yeah.
Well, actually, maybe a slightly different question. Do you think this course will be created as like an online first course, or do you think it will have to come from university? Because like I could see it going both ways actually for this.
I think it can go both ways. Yeah, I mean, I think probably even if it does come from a university perspective, I expect the material to be like online and accessible, like the assignments and the lectures recorded, all that stuff. Like we've been seeing that for some of the more theoretical ZK courses, like ones by Alessandro Chiesa, where sort of it's basically open to anybody on the internet to sign up on the Piazza and like attend the lectures and so on.
I mean, I don't want to toot our own horn, but I know that ZK Hack 1, the original, had been used as a boot camp. Who's in the audience there? So that was really promising. I definitely at least envision some sort of learning path that's very kind of asynchronous and non-planned out and not particularly like academic, that could be obtained through a lot of the material that's being developed right now, but it's still very chaotic. And I also know like, it's almost like we do see parallel courses like a lot of different projects are doing a learning center of their own, kind of bringing, oh, yay, Chitra got a job too. That's so cool. What a great path. Anyway, sorry, I'll put that one up. Yeah. But yeah, I do wonder if there's not sort of an overlap of education happening right now. So there's like a lot of teams who've raised a lot of funds and start a learning center of their own. They're kind of doing the same type of education over and over and over again, but it doesn't always go to that next level. Like that early stage entry point seems to be somewhat well covered. The like high levels, what is it? Where's Waldo? Alice and Bob, that kind of stuff seems like there's a lot of video content around that, but not that middle area as much. And yeah, I know we're trying to sort of solve for this with ZK Hack, and we have some plans around that as well.
Yeah. If
cool.
I can add like one more word about it, is that I think students need to have good grasp of fundamentals so that they be able to understand new things and new construction, and especially maybe being an engineer in heart, they need to understand what people promise them. Like papers sometimes talk very abstractly about, oh yeah, you have a random oracle, it's very nice. Like, what is it? How do I use it in practice, right? And it's very dangerous if you don't understand what you're being promised or what you have to promise when you use a system. So knowing that touch points is important. And I really believe that learning through doing and like learning through applications is a really strong motivator to get to understand internals of systems, and especially through failures, which is again what we do in ZK Hack, which is like a big believer of that. So,
yeah, totally.
Mm-hmm.
Actually, yeah, we're starting to come to we're not quite at the end of the session, but we are going to be prepping for the job fair coming up right after this. I know Tanya's talking about it a little bit in the group here. I had one topic that I wanted to touch on, which I think is really quite relevant. And then this maybe is our last one. I do want to actually welcome anyone to add extra questions or thoughts in the chat as well. But this is around like the use of ZK privacy tech in the world at this very moment. Like given some of the things happening, I know this has come up in conversation where we were like, is ZK tech going to be used as a force of good to get funding potentially into conflict zones where funding's very much needed, but privacy is needed? Or will ZK tech be used to avoid sanctions? Or I don't know, like there's lots of different ways that this can be used. And I'm wondering if any of you have been thinking about that. Also, if anyone in the audience.
Wait, is it just Anna or is it me?
I think it's just Anna
it's
first.
Anna, yeah.
Okay.
Yeah, sorry. You first.
My video again? Oh no. Did you hear the rest of my question though?
Nope.
Oh, really? Okay. So I'll start that again then. The question here is, do we see ZK, shifting gear, looking at the state of the world, do we see ZK as a tool for potentially helping, I don't know, in conflict zones to get private funding into the hands of people? Or do we actually see this also being used for sanctions? I mean, I guess it could be used for both, but are you thinking about it? Are there ways that we can, I don't know, in our industry help to direct the development in one direction or another? Or maybe we can't, since it's all free, open source. I don't know.
I guess I just want to say, I think the proper analogy here is, this is like the 1920s when we're discovering alpha decay and like all of these like sort of properties of like heavy atoms. And, I don't think the point is to like, while you're doing that, a fundamental thing, to start thinking about like, oh, in 20 years it's a nuclear bomb. Because like it actually will just ruin your ability to kind of like isolate, like you're not, especially if the applications aren't ready. Let's suppose this whole industry, it turns out nothing works, like no real application can ever get built, worst case scenario. Then, it's kind of worse to have, I guess, started by assuming like this whole world is ending thing is going to happen. And I think once the tools are there, then you have to think about this stuff. I think it can cloud your decision making.
It's almost like it's so unusable at this point. We don't need to worry.
Yeah.
What you're saying?
Yeah. I mean, that's why I made
God damn
the
it.
alpha decay thing, right? It's like sure, Marie Curie did not the path from Marie Curie to nuclear bomb was quite nonlinear.
Fair.
I kind of agree and I kind of disagree. I think it's valuable to think of the tech you're building in the sense of, what changes you want to see in the world and what changes it could have in the world, right? So I think it's important to think of that, not necessarily to self-censor, but to at least have that in the back of your mind as this is a possible application. I will say though that I don't think bypassing sanctions is a negative use case for zero knowledge stuff, because if you're a rich oligarch in Russia or whatever who is using this to money launder, you're gonna get caught because of other means anyway, and all these sanctions end up doing generally is just harming the average person in Russia who has nothing to do with any regime, or in Iran or Venezuela or whatever, right? So I think I think what we will see is it will be used for all kinds of use cases. But I think, as Alex is saying in the chat, I think somebody else also, Keelan, has mentioned earlier, is that you can, I guess what this privacy tech gives you is sort of selective disclosure, right? So you can enforce even with ZK that, if your transaction is above, say, $10,000, then revoke anonymity or something, or encrypt the sender, receiver, and amount to some KYC authority, for example. So you can have average case privacy while still maybe allowing for disclosure in exceptional cases or in the case of a warrant or whatever. And this sort of goes into a very sort of long-standing debate in the crypto community about building in backdoors into your tech. So there's a lot of discussion that's gone on in the space. I think that we should be trying to maximize privacy, given that the rest of the world is working very hard to minimize privacy. So I think carving out this niche where we do have a private environment and people are able to talk freely and without sort of fear of censorship from states, from other people, etc., I think is valuable.
Cool. All right. Well, I don't really have any more questions. I don't know if there's any more questions in the chat. I know there's a bit of a delay anyway, but I guess we should potentially wrap up. I don't know if any of you have anything else you want to share.
I think
Alex's point about the contrarian part. I do feel like that there are definitely teams in ZK land who certainly believe that quite strongly, that it will improve compliance, not worsen compliance. I guess Espresso, I think, explicitly stated this to some extent. So,
yeah, I think Alex also had this question about how do you describe a polynomial commitment scheme to a friend.
Yeah, well, we can actually put so the reason this comes up. This is the ZK Summit filter question. So yeah, I think maybe we can share the link again. I actually have sort of our wrap-up slides where I do mention that. I hope to see a lot of you in person in Amsterdam in just over a month. So hopefully you can make it over. I know traveling right now can be treacherous. I know a lot of people I feel like a lot of people went to ETH Denver and left being like, I'm never traveling again. But please don't give up on all of us over here in Europe. Maybe you head over. But yeah, one of the questions is how to describe a polynomial commitment scheme to a non-technical friend. Okay, now go. See if any of you can do it.
I forgot my answer when I submitted the application. I'm trying to remember it, but other people should go.
I'm doing the same.
Well, we're gonna try to find a way to actually showcase some of these answers at the event. Because every time I do this, there's so many funny answers and I can't actually share them all. So we're gonna try to find something to like show it off. But I think what we should do right now is wrap up this panel. And I think some people have already shared the link to that. That's awesome. And I think, yeah, we should also wrap up and head over to Gather, where we're going to be doing our job fair. Somebody's asking, is there a live stream for the ZK Summit? I believe there will be on the main stage. Maybe not the whole event, but we're going to try to do something live. Yeah, so I hope to see you all there. I think we're gonna wrap this up now, and we're gonna share our links in the chat. So see you in a bit. See you soon. Ciao, ciao.
Bye,
Thanks
everyone.
everyone for the panel.
Mhm.